per time lapse. This is part 2 on your lab packet, glass manipulations. So very often in chemistry, we have to use glass tubing like this. So this is a piece of bent glass tubing. We use these for doing gas collections. We use these for directing the flow of liquids, things like that. Now, in order to use this, we very often have to insert it into either tubing, like this piece of latex tubing, or the hole in a stopper. And this is a stopper that goes in an Erlenmeyer flask. It's got a hole in it, and we use that for gas collection. If you just try to jam this in here, it's not going to go. And the only time that I've ever had to write up an accident report on a student in chemistry, it was one of my very early years teaching chemistry, and I didn't catch out of the corner of my eye that the kid was not doing the process correctly, and he pushed the glass tube and it snapped, and the broken glass tube went right into his hand. It's a lot of blood. Oh, it's a lot of blood. So I do a better job these days on watching kids with glass tubing. But the first thing that you're going to notice is I've got these big, fat terry cloth gloves, and I actually have 2 lefters, but that's okay. We got what we got. These are actually called Autoclave Gloves, and they're like hot pads that you wear. You can pull stuff right out of a sterilizing oven or an autoclave using these, but they're also really good for protecting your hands when you're dealing with glass, because you're not going to puncture this with a piece of broken glass tubing. This is glycerin, and glycerin, if you've ever blown bubbles, one component of commercial bubble solution is actually glycerin. Glycerin is like an oil. It's a vegetable-based oil. It is an ingredient in some cosmetics and creams, but in the chemistry lab, we use it for lubricating glass tubing. Okay? And you will not ever use this, like you wouldn't rub this into your hands because I'd kick you out of my lab. It's a chemical supply. So I'm just going to put a little bit of glycerin on this paper towel, and I'm going to lightly lubricate the end of the glass tube. Now I'm going to make sure I've got my gloves on. And with that tube well lubricated, and it is hard to manipulate the tubing with the big fat gloves, this will slide in here like a hot knife through butter. Goes right in, okay? With no lubrication, you are fighting this the whole way, and that's when you're most likely to break a piece of tubing and have an accident. Now, and I think, well, I of course managed to grab the one stopper in the lab that's a little bit smaller than the glass tubing. You can sort of just see the hole in that. We may not be able to get that in there, but we'll try. So, I've again lightly lubricated the end of the glass tube. And every time I do this, I fight the urge to take off my gloves to make handling the stuff easier, because my brain is telling me, oh, you can't do this with these gloves on. But that's a really bad idea, and that's how disasters happen. So I suspect that these are a mismatch, but I'm going to go ahead and see. So, I mean, not lubricated, clearly there's 0 chance. Yeah, okay. This one's got too small a hole. Let me grab a larger stopper. Well, we'll stop there. The way that this setup is most frequently used is for gas collection. If we are running a reaction in this vessel, in this Erlenmeyer flask, that's collecting gas, and we want to take that gas and capture it someplace, we use a stopper with a tight-fitting glass tube and then some flexible tubing that leads to whatever vessel we're going to collect our gas in, usually a gas collection jug. Okay? that's the entire demo for part 2.